Dear students, we have been continuing with the road furniture, and in the previous interaction we were discussing about the road signs, the categories of road signs in terms of the information signs and the facility signs or the different specific signs which can be there. And towards the end we were talking about or discussing the placement of those road signs. We could not complete that, and in today's interaction we will first start with that part of the leftover section of the placement of signs, and then we will go ahead with the other features like road delineators, speed breakers and kilometer stones, and we will see that if we can complete up to this point in this particular lecture. Starting with the placement of signs, apart from the various distances which have been talked or the distances in the horizontal direction or in the vertical direction which needs to be maintained, while the signs are being provided at the side of a carriageway or a shoulder or on an embankment or in a cut section or a hillside. The another thing we talked towards the end was the gantry girder, and that gantry girder is actually the overhead sign, and this overhead sign is required to be provided under different specific conditions which may prevail on a road. So, what are those conditions which can be there are like there is a high speed traffic, and therefore, if you provide these signs at a height of something like 2 meters to 2.5 meters on the side of a carriageway or a shoulder, the drivers may not be able to visualize and apprehend and what is being depicted. So, it is always better to provide in the front side and towards the top. Then traffic volume is at or near the capacity. So, it is a choked condition which is there. There is a complex interchange which is reaching. So, you have n number of entries and exits, or there are different levels, and if you take different levels you reach different directions. So, we need to tell that in a very clear manner that how you are going to proceed. If there are 3 or more than 3 lanes in one direction, then also it is always advisable to go for overhead signs. If there is a restricted visibility or there is insufficient space on the ground, some restricted conditions are there, then also we should try to go for gantry girder based things. If there is a large proportion of commercial vehicles, CV is commercial vehicles, say trucks. So, if big trucks are there, then the vehicles which are smaller in size, the drivers in those particular vehicles will not be able to see what is being depicted on the left and right of the carriageway if the signs are being placed there. So, in those conditions also we should go for overhead signs, or if the interchanges or the junctions are very close to each other, then that is another case. So, likewise there can be different conditions under which the overhead signs needs to be provided. I have tried to enumerate most of the conditions which are there. Now, when you are placing them, now how you are going to orient them with respect to the direction of travel is another important thing needs to be looked at. In most of the cases it is found that they are being placed at right angles. So, they are coming in this direction. So, the sign if it is there, then this sign will be facing in this direction. So, you are able to see that what is being depicted. But in few cases if there is a problem of light reflection and the reading of that particular sign is a difficult situation because of that, then one case which is being done is instead of using 90 degrees, additional 5 degrees are also being used and it is made as 95 degrees. So, that now that reflection is not coming. Now, parking signs, they are being placed and they are placed at 15 degrees to the carriageway. So, that is the angle which we are going to maintain here. On the gradients, if you are moving on an upgrade or you are moving a downgrade, so that is the situation. So, what you have to do is either you have to do in this manner or you have to do in this manner. So, they are being tilted forward or backward from the vertical to make it normal to the line of sight, and that is how the the viewing is going to be improved. The another thing which is there is that if you are looking at here, that the angle at which the things have to be provided. So, there is a certain angle by which you are going to look at on the side of this, and that is what is entrance angle being defined. So, you have this particular sign here and the reflector axis is this one. So, if you are at an angle, then you are not going to get a glare. So, that is another thing which needs to be looked at. Now, so as to improve upon the legibility, we may have the signs which are having words written in either the lower case or an uppercase. In the case of uppercase, they are simply being defined in terms of 1.4 times the size of the lower case, where the size of the lower case is dependent on the speed, and that is what is being defined here. So, the speed which is 30 kilometers per hour or less, or is going to up to 120 kilometers per hour, depending on that, the minimum and the desirable values of the lower case letters has been defined, and it is 60 mm at a least value and desirably 75 mm, but as the speed increases up to 100, then it becomes 150 and desirably 200, and if it is more than 100 kilometers per hour, then it is 250 and desirably 300 mm. And as I said previously, there is a possibility of having a definition plate at the bottom of a sign, then the letter size on the definition plate should be 50 mm or 100 mm, depending on again the speed. If it is a high speed, then we should go for 100 mm. Now, here again we are talking about continuation of the previous discussion, the placement of signs. The visibility is another criteria. You have provided a sign, but it is not visible. A sign has a retroreflective material which is being used to show the colors in terms of maybe green, orange, white, black, whatever is being utilized there, or even say the blue is also there. So, in this diagram you have a sign here which may have those retroreflective colors. So, there is an illumination axis and there is an observation axis. This angle is going to be there, and this angle is correlated with the coefficient of retroreflectivity of those particular colors. Here the values have been defined as 55 meters at a speed of 30 kilometers per hour and 160 meters at a speed of 81 to 100 kilometers per hour. So, this is just tentative idea which is being given to you. So, you can interpolate the values in between, and even if you are going to a value of 120 kilometers per hour, so it may be somewhere around 180 meters. Now, in the case of grade separated junctions, these signs are located at 250 meters to 750 meters from the junction, and at the same time there is a repetition of that which is at additionally 750 meters to 1500 meters from the junction. So, there are two locations where you are going to tell the drivers that you are approaching a grade separated junction. There is also a reassurance sign. This reassurance sign is that you are on the same path, you are on the same route which you are taking up. So, you are moving on a national highway 58 and you have reached an intersection, you have crossed the intersection, and that intersection has multiple legs. Now, which particular exit you have taken, have you taken the right exit or not, has to be defined by way of placement of this reassurance sign, and this reassurance signs are placed within 100 to 150 meters from the junction, so that if any fault is there, any wrong decision is there by the driver, then the driver has a sufficient time so as to rectify it, come back and take the right exit and take the right path. This is quite important. You cannot provide it at something like 1 kilometers or 2 kilometers. Similarly, place identification sign. You are approaching a built up area. So, what is this built up area where you are approaching? So, these signs should be 90 meters to 150 meters in advance of the start of that built up area. So, with this we have completed about the road traffic signs and their placements. Now, let us move in the another topic, and this topic is again related with the safety, and to ensure that the traffic which is moving on a particular section where there are certain constraints. Now, there is no issue with respect to the safety of anybody, including the property. Now, these delineators or hazard markers, these can be of any type. These can be flexible, reboundable or portable. Say if you look at here, this is a cone. So, this is a portable type of a system. So, you can take them wherever you need to use them. You can see here this is a reboundable condition. So, a vehicle has hit it. Now, if the vehicle goes back, then this will come back to its and it will come to the same erected position as being shown in the other one, or they can be also placed in such a manner. So, they are being fixed in place, but if you remove these bolts, then they can be moved to the another location. So, the different type of varieties of these hazard delineators or markers can be there. They can even mobile in nature. So, wherever there is a requirement, we have a vehicle on which these are being placed, and that shows that there is something happening here, but when as soon as it is over, then you just move ahead, and that is where there is no need of something like erection or taking in and out of a material from that vehicle. These can also be provided as a metal system. You can see here, and this probably you have seen at different locations. Say this is a median, and at the top of median, what you can find is here the color yellow and black is being shown, which defines that you are approaching an object here. So, this is a color being used, and at the top of that these two metal delineators have been provided, where in the top of these delineators a color is being used. So, this color is like a red or orange and yellow and white, and during the night time it will reflect, and that is how the drivers will be able to understand that there is some object in the center, and therefore, they have to deflect to the side. Now, when we are talking about these delineators, what are the requirements which needs to be ensured? The very first thing is the visibility. So, they should be visible. So, the whatever color codes, whatever designs etc., has been utilized, they should make them visible. Reflectivity is another important thing, because if during the night time, if they are being placed at any of the location, then the reflectivity will ensure that the drivers will be able to see it when the light beam falls on that. They should be light in weight. So, that is another thing, because you have to make use it LED based, and this LED based will help in the reflectance of whatever beam falls on that will get reflected, and in terms of a color coding it will define what type of a constraint, restraint or no restraint is there. If they are in terms of a post, then they should be 70 to 90 centimeters in height. So, this is what we are talking here. So, this is 70 to 90 centimeters above the surface, and of course, they are going to be embedded inside. That is how the safety of these things can be ensured. Different colors can be utilized, and these colors are going to depict the condition which is there at a road. And the pedestals for bolting to the surface is another thing, if they have to be fixed in location. Now, the another thing is that there are requirements of safety barriers, or there are requirements of ensuring the safety in those zones where certain works are going on. So, in such cases, again we are going to utilize certain things. So, why we doing it for the segregation. Now, segregation is of the path or the lane on which the vehicles are moving with respect to the side where the work is going on, or there is a possibility that some vehicle has gone out of control, and therefore, that needs to be controlled in a sense that there is no hazardous situation arises because of that out of control vehicle, or that system can be such that it reflects back that out of control vehicle to the traveled path. So, there are different things which have been utilized in different parts. What you found is that there is a crash barrier. So, this is a metal crash barrier. This is a concrete barrier which is being provided, okay, and say there is a hardened plastic barrier, or there are railings which can be there. So, if you are talking about these different type of things, like when you talk about the metal crash barrier, this design is usually being provided in such a manner that if something hits here, the vehicle should try to come back on the road. And but when this type of a hit is there, then there is going to be some impact on this particular system. But when you are looking at the concrete one, then there is going to be a lesser of impact on this type of a barrier, unless and until that crash which has happened there is quite high in intensity. Now, these railings also will try to deflect, and because multiple rails are being provided, it ensures that the vehicle is not going to the other side, and the same is the case in the plastic one. There are other ways of doing either the closure of the road or depicting that there is some hazardous situation at some point. So, the cables are being used, and these cables can be like ropes, or these cables can be like a chain, or they can be this type of a jig-jag system, which is mostly the plastic based system. These systems are soft in nature, in a sense that if some vehicle hits here, then there is not going to be a much of loss to the vehicle, but yes, in the case of plastic things etc., we may find that we have to replace them. So, when you are looking at these type of barriers or things, then they can be defined as a flexible, semi-rigid or rigid barriers. Now, when you are looking at the flexible barriers, then these flexible barriers are usually, as I have shown you previously, like these particular cases. So, these are wire rope based systems or a chain based systems which are being provided between the fragile post. This will cause a minimum of an injury to the vehicle, but there is a possibility that if any motorist two-wheeler hits on that, then that is going to be a more riskier for them because they may fall on the other side. So, it deflects more, but at the same time it need repair following the impact. If you are talking about the semi-rigid, which is something like rails or the steel beams like crash barriers, steel metal barriers are there, they deflect less and they can be located closer to the hazard and they are able to redirect the secondary impacts. So, that is one advantage which can be there, but when you look at the rigid barriers, then they are concrete based barriers. They are used at high volume work sites to protect the workers because they are bulky in nature. If some vehicle hits them, it is not going to move to the other side, but that is how the safety is ensured of the workforce. So, they are not going to deflect and there is a highest level of containment of the heavy vehicles, but following the impact these barriers require little or no maintenance. So, depending on what is the situation, what are the requirements, what are the conditions prevailing on a road, a type of barrier can be utilized. Now, here what you can find is that there are three categories of barricades which can be moved easily or not easily depending on their sizes. Now, we have type 1 and type 2 and another case is a type 3. Now, type 1 and type 2 they have been defined as 1 and 2 and this is a 3 case. So, the type 1 is usually being used at those locations where we are going to control related to the pedestrian traffic or there is a low speed traffic which is there, then this type 1 is sufficient to be worked with. And what you found is that there is this plate on which the alternate white and orange strips are there which are inclined and they defines that how to move, but at the same time they are folding in nature. So, you can fold them and can take to another location if so required. By the type 2 this is being recommended on such situations where the speeds are higher. So, it may be high speed multi-lane facility or expressway etc. Type 3 barricade is more specific in nature, it is bigger in size, it is more bulkier and that is why it is very difficult to keep changing its position now and then. So, this one is usually being utilized so as to define the conditions where there is a detour, means you have the road closer, you have to go to some other side or there is heavy equipment around and you have to protect that from the impact of the vehicles of those which have gone out of control or any other such big type of control is there. In those cases this type 3 barrier is being utilized. There are other miscellaneous barriers which can be there like a boom barrier which usually is being provided say in the case of toll plazas or there is a restricted area and the entry at that or exit of that, these boom barriers are being provided which are controlled from the booth at the back. Now, the barbed barriers or the fencings are also possible, mostly they are being provided at the end of the road boundaries if you are in an open area or if you have to segregate the surface road with respect to the main carriageway, there also we talked about the fencings. There can be a steel railings which can be provided so as to distinguish between certain things or a crash barriers, and what you can see is that all of these things they are related and they are being enumerated in the Morse guidelines under 800 section. Now, once we have talked about the safety features which have been ensured by way of say the provision of these things in terms of barriers etc. The another feature which is required on the surface of the pavement so as to control the speeds wherever so required is the speed breaker. Now, these speed breakers when they have been provided, they should be designed in such a manner that they should not cause any discomfort to the passengers as well as the drivers. and when the vehicle moves at the top of it, then these should not cause any damage to the vehicle base. So, we need to have a very smooth design, we need to have to see that what is the height of that. So, when you are talking about this, we are talking about the design in terms of length and profile. We are talking here in terms of the specifically height, because we are talking about the vehicle base. So, there is a certain clearance with respect to the clearance of a vehicle. We need to see the what can be the height. Now, when the vehicle moves at the top of it and they are moving at a certain speed, it should not cause noises or vibrations. So, that should be another thing. So, material whatever you have used and all those things needs to be taken care of. But at the same time, if there is a vehicle which moves at a speed which is more than the design speed of the speed breaker, then in that case there should be a increased level of discomfort to such vehicles, to such drivers. So, that is also need to be ensured. So, it means we also need to look at what is going to be the design speed, we need to look at the height, we need to look at the length, and we need to look at the profile. So, all of these things are the design features of a speed breaker. Now, what are the conditions where the speed breakers needs to be provided? Now, these conditions which are there, they are like T intersections, where the T intersections are having a major road and a minor road. So, in the case of a minor road, we need to provide it. On a high speed facilities, those intersections are there, or the locations where there is a history of the crashes, we need to go for it. The priority intersections or the mid block sections of urban roads where the speeds needs to be controlled, or there are stretches where the traffic is moving at a higher speed than the safe speed, and therefore, the speeds needs to be controlled, so that the safety of the other road users can also be ensured, like near universities, hospitals, etc. So, they are the typical things where typical conditions where the speed breakers needs to be provided. So, in continuation of these conditions, now we can translate maybe in the form of a locations where the speed breakers are going to be located. So, if we look at that, then in that case the intersections with the minor roads, this is one thing we talked, the locations with the possibility and the record of accidents, near the sensitive locations like hospitals, schools, etc., so that the speeds are lower, and if there is any eventual condition or any interaction which between the other road users with these vehicles, then there is not going to be hazardous. At the railway crossings, at sharp curves, in the areas with the ribbon development when it is passing through a built up area, because lot of activity is going to be there, or the mid block locations where the speeds needs to be controlled. So, the conditions and the locations, they are correlated with each other, and that is how you can try and make it out by yourself, that what are the locations where the speed breakers needs to be provided. Now, when we said that we have to look at the design of the speed breaker, the very first thing is the profile. So, what should be the shape of the speed breaker, and the shapes can be either circular or trapezoidal in nature. Now, you can see here a very good design where just see the what is the length of cord, and at the same time the profile which is circular in nature, and therefore, whatever vehicle is going to traverse on that, it is going to be more smooth. So, we are interested to provide such type of a good design. So, when we are looking at this, and I said that these designs are also going to be affected by the speeds of the movement of vehicles, and in an urban area we also need to look at more specifically towards the buses, because you may have the city buses, BRTs, etc. So, when you are talking about the circular type of a design which is being shown here as one, what we see is that the height of this circular section at the topmost point is up to 100 mm. So, that is the limit. 100 mm is the limit of the height of these speed breakers, and most of the time you will find that in the case of a four wheelers, the ground clearance which is there of the vehicle base is more than this, and therefore, we ensure that there is no damage going to be there to the vehicle base. Another thing is the radius. and this radius, as you see, changes from 11 to 180 meters, and that is all dependent on the speed with which that vehicles are going to traverse at the top of this speed breaker. And depending on this particular radius, then the chord length is going to be 3 to 12 meters. If we look at the another design 2, which is a trapezoidal design, in this case the slopes are going to be there on either side, and there is a straight section and a flatter section at the top in between, and this is minimum 2.5 meters. And based on this x% slope, there is going to be a length of the ramp, and the height is being restricted again up to 100 mm, at a minimum is 50 mm in this cases. So, if we look at these, and if you are talking about a circular one, what we found is that the speed is changing from 20 kilometers per hour to 50 or more than 50 kilometers per hour. And with respect to that, there is a radius which changes from 11 to 180 meters, and the chord length which changes from 3 to 12 meters. And if we try to make some relationship between the chord length and the radius, then it is something like 3.5 times, or the radius is 3.5 times of the chord length, or this is 4 times or 5 times or 6 times, or then this is something like 8 times, 10 times or 12 times of the values which are going to be there. So, some sort of that relationship maybe as thumb rule can be made it out here. If we look at the speed of the buses, then the speed of the buses, they are reducing by 15 kilometers per hour with respect to the design speed being taken. So, if you are talking about a design speed of 20 kilometers per hour, it is expected the bus is going to traverse at the top of that with a speed of 5 kilometers per hour. And if you are talking about a 50 kilometers per hour, then it is 35 kilometers per hour. Let us look at that how it translates in the case of a trapezoidal one. Now, in the case of trapezoidal one, the speeds are again changing from 20 to 50 kilometers per hour or more than that. But here the two things which we are looking at is the gradient and the length of the ramp, and the length of the ramp is changing from 0.7 meters to 4 meters, and the gradient is changing from 14% to 2.5%. So, obviously, as the gradient is becoming flatter here, then this is increasing. So, length of the ramp is increasing because you are getting this flatter system. Now, when you talk about the bus step in this case, then what you found is that this is minus 20 kilometers per hour. So, if you are talking about 50 kilometers per hour as a design speed for the trapezoidal speed breaker, then the bus is expected to move at a speed of 30 kilometers per hour at the top of it. So, that is how the values have been looked here. There can be other designs too. Now, of course, we talked about the trapezoidal sections or the circular sections and all. Now, one another thing which can be there is a combination of these two. So, you may have a circular section in the center and the trapezoidal sections on the side, and that is how the gradients are going to be there and the radius is going to be there, but the height remains maximum as 100 mm in that case too. Now, the next thing which we should try to look at is the placement of these speed breakers. Now, what you can see is that this is a mid block location, and on a mid block location the traffic is moving in either of these directions, and we have provided a speed breaker here, and there is a sign, and this sign is at a distance of 50 to 60 centimeters, not centimeters, meters from the speed breaker, and this has to be provided on both of the sides. And this speed breaker is not being provided with the same texture of the carriageway, and we need to make it distinguished, and that is where the black and white alternate strips of 500 mm width with the 500 mm spacing are being provided. So, that is the way the arrangement can be there, but the another way, another design can be that when the traffic is moving in these two directions, then we are utilizing these tips of the arrows which points towards the direction in which the traffic should move. So, that is how, that is another way of providing these markings. Now, if you have an intersection, then how we are going to place them is what is being shown here. So, we have a major road here, and we have a minor road on this side, and this is a T junction. Now, the speed breakers are going to be provided obviously on the minor road, and there are two locations at which they have been provided. So, one is at a distance of 10 meters from the edge of the major road or highway, and that is where we are providing this. So, whatever is the design, on the basis of that design is speed, rest of the things will come. And then there is another one which is provided at a distance of 100 meters to 120 meters ahead of it. So, this is a pre-warning that you are reaching there, and just before that at a distance of 50 to 60 meters we have the sign which says that there is a speed breaker ahead. Apart from that, we also need to tell the drivers that you are reaching a major road, and therefore, this is provided at a distance of 60 meters from the center of the speed breaker, which is very near to the intersection. Now, this is one arrangement which we are talking about, but at the same time when you are at this location as a driver, you are coming from this direction, we need to ensure that how much area is being visible to you. So, this much area needs to be visible, and that is being defined by way of the center line of the minor road, and with respect to that center line of the minor road, we are taking a distance of 180 meters in this direction and 180 meters on that direction. So, we get a point here and we get a point on the other side, and that is how a sight triangle has been created. So, this sight triangle should be clear of any obstruction. So, if there is any obstruction here or if there is any obstruction here, then they should be away from this particular line of sight. And on the main highway, you have to tell on both of the sides that there is a side road ahead, and this is being placed at a distance of 120 meters from the center line of this minor road. And then the next thing which we need to look at is that the placement at the sharp curves. Now, in the case of the curves, we need to maintain the safe stopping sight distance. It means the first installation which is going to be there of the speed breakers is at the extremity of this SSD, and then at a distance of 100 to 120 meters ahead of it, there is going to be an advanced speed breaker location 2, and we are going to tell to the drivers that there is a speed breaker ahead by way of a speed breaker ahead sign, which is being placed at a minimum distance of 50 meters ahead of that. So, that is how the speed breakers are going to be placed at different locations and different conditions. Okay, so, with this we close our interactions today, and that is how you can see that this is a circular one and this is a trapezoidal one. A good design is being shown. We are going to talk about the kilometer stone in the maybe the next interaction, and till then we are going to close our interaction for today, and thank you and bye.